All right, and welcome back. So today we are going to be going through a couple of different examples of exponential growth as well as exponential decay. So without further ado, let's get started. So in this first example, we have a function y is equal to 1,200 times 1 plus 0.3 all raised to the power of t. Does this function represent exponential growth or exponential decay? What is the initial value and what is the rate of growth or decay? So typically, we won't see this written out as 1 plus 0.3. We are going to see this function as y is equal to 1,200 times 1.3 to the t. But since it is written with the plus, it is easier for us to identify that this is an exponential growth. So this is an exponential growth. What is the initial value? The initial value is going to be the a value, so the number that's getting multiplied by this repeated factor. So it's actually going to be this 1200 is the initial value, or 1200 I should say. And what is the rate of growth or decay? Well, we know it's not decay because we've already established that it's a growth, so I'm just going to cross out decay for us. And we want to look at, okay, what is that rate going to be? Well, your rate is 1 plus whatever the rate is, right? So the growth rate is 1 plus your rate. Well, 1 plus our rate, well, we have 0.3. But that's as a decimal, and we want to transform that into a percentage. So our rate of growth is going to be 30%. If we were given, let's say, this right here, this part, 1.3, all we need to do is just take 1.3 minus 1.0, and that's going to give us 0.3, which is what we get down here. All right, sweet, nice job. Here we go. In this example, we have y is equal to 55 times 1 minus 0.02, all raised to the power of t. And again, we would typically see this. Let's see if I can move this. Haha, I can. We would typically see this as y is equal to 55 times 1 minus 0.02 is actually going to be 0.98 raised to the power of t. Does this function represent exponential growth or decay? Well, since it's less than 1, it's going to actually be decay. It's going to be exponential decay. What is the initial value? Again, the initial value is our a value, the number that's getting multiplied by the repeated multiplication. So our a value is going to be 55. And what is the rate of growth or decay? Well, we've already established that it's decay, so I'm just going to cross out that growth for us. So we have our general rate being 0.98. So what we need to establish is what is going to be that rate of decay. And a way to do it is to do 1 minus whatever we're given. So 1 minus 0.98, and we get 0.02. And that should make sense because we were given it right here. So our rate of decay is going to be 0.02. All right, sweet. Here we go. Ooh, word problem. So it says you are starting. Your starting salary at a company is 34,000 buckaroos, and it increases by 2.5% each year. It's asking us to write an exponential growth function to represent this situation, and then what will your salary be in 5 years? Round to the nearest dollar. All right, so it says we're going to be increasing by 2.5%. So that tells me I have growth. So since I have growth, it's going to be y is equal to a times 1 plus r raised to the t. All right, let's see what that transforms into. What is our initial value? What is our starting salary? Well, our starting salary is 34,000. and we're going to be multiplying that by 1 plus our rate of increase, or our rate of growth. And if we're increasing by 2.5%, well, 2.5% as a decimal is 0.025. So we're just going to do 1 plus our rate of 0.025. So 1 plus 0, or 1 plus 0.025 is going to give us 1.025 raised to the power of t. However many years this is going to be occurring. All right, so if we take that down to section B, y is equal to 34,000 times 1.025 raised to the t. It's asking us, hey, what is going to be your salary in 5 years? So our time is going to be 5. So let's substitute that in. And now we take out our calculator and we can plug everything in. Let's do that right now. 34,000 parenthesis 1.025 and parenthesis caret 5. Let's see what we get. We get 38,467.88, but the directions tell us to round to the nearest dollar. So really, it's going to be 38,468 buckarooskies. It's a pretty nice salary. All right, here we go. And our last example says the initial yearly profits of a company is $25,000. The profits have sadly been decreasing by 6% each year, and they want us to write an exponential decay function to represent the situation, as well as figure out what will the profits be in 8 years. We again want to round to the nearest dollar. So let's fill in what we know. Write an exponential decay function. We know it's going to be decay. So it's y is equal to our initial value a times 1 minus r raised to the t, or the power of t, I should say. So what's our initial value? Well, our initial value, or our initial profit, is 25,000. And typically we see a lot of money equations and situations with exponential growth and decay, as well as you might see a lot of germs and nature and atoms and molecules. So there's a lot of science in this as well. So 25,000 times 1 minus our rate. Well, what's our rate? It says it's decreasing by 6% each year. So it'd be 1 minus 0.06. Now, a lot of students confuse that. They might write 0.6. That's 60%. We're looking at 6%, so it's 0.06 raised to the t. But we know that we can do 1 minus 0.06, so I'm going to erase that. And I'm going to simplify it for us. So 1 minus 0.06 is 0.94. So that's going to be our exponential decay function. Let's translate that down low under part B. 25,000 times 0.94 raised to the power of t. And it says, what will the profits be in 8 years? So that's what we're going to use for our value of t. So y is equal to 25,000 times 0.94 raised to the power of 8. So let's plug that into our calculator. Let's see what we get. 25,000 parenthesis 0.94 end parenthesis caret 8. And we get $15,239. And that's rounded. We get 15,239.8 1.22. So we round down and we keep it at 15,239. So they're still generating a profit, but as you can see, over the next 8 years, they're almost $10,000 less than where they started out. But they're still generating profit, but we can still see that we are starting to lose money. And that should make sense because we're talking about decay and we're not talking about growth. All right, folks, great job today. So proud of you. If you have any questions, please feel free to reach out. But other than that, have a great day.